Welcome to the MCAT Basics Podcast, brought to you by the physicians at Med School Coach. Each week, Sam Smith breaks down high-yield MCAT topics so you can score as high as possible on test day.
Hello and welcome to Prospective Doctors MCAT Basics with your host Sam Smith. The goal of this podcast is to cover the highest yield topics on the MCAT and provide you with some sort of insight into the questions that the MCAT really likes to ask. This podcast is going to cover aging. I'm first going to dive into some biology and talk about aging at the cellular level. And in this part, I'm going to cover cell senescence as well as telomeres. Then I'm going to talk about aging in the brain. Then after that, I'll look at aging through the lens of psychology and sociology. At this point, I'll be talking about aging in the life course, the social significance of aging, and finally, the demographic structure of society in terms of aging. As you can guess from that intro, this is going to be a twofer. You're going to get two sections here, the biochem section, as well as the psych-soc section. So with that said, I hope you find this podcast helpful in your studies, and good luck as you prepare for the MCAT. Okay, the first thing I want to do here is talk about aging at the cellular level, and then I'll get more into what happens at the macroscopic level with a discussion of aging and memory. So first off, I want to answer this question. What is cellular aging? Obviously, cells don't grow gray hairs and they're not going to pee 4 times a night. And so how are you going to know that these cells are aging? So there are numerous markers that indicate cellular aging or indicate cells being old. A few of these are protein aggregation, telomere shortening, cell senescence, autophagy dysregulation, as well as mitochondrial dysfunction. Now, what I want to do is break down each of these different indicators or markers a little bit further. So I'll start with protein aggregation. As cells age, they're not able to maintain their proteins very well. In other words, they're not able to maintain proteostasis. That's just a word meaning homeostasis of proteins. Now, as a result, what happens is that proteins don't fold correctly or they're damaged. And then once these proteins don't fold correctly or they're in a damaged form, they can then aggregate and form these insoluble clumps of proteins called plaques. And then these plaques can cause problems for cells down the road. I mean, I'm sure you've heard of it in Alzheimer's, for instance. These plaques that occur within neurons cause a lot of damage. So that's one sign of cellular aging. Again, that's protein aggregation. The next marker is telomere shortening. I'm going to talk more about that in a second, just because it's pretty important. But the short of it is that the ends of our chromosomes contain these short non-coding repeats that basically protect us from losing genetic material each time our cells divide. And so the more our cells divide, the shorter the telomeres in those cells get. Again, more on that in a second. The next is cell senescence. And by the way, this word should be in some type of spelling bee. There's so many S's and C's that I literally can't spell it, even though I've spelled it 50 times for this podcast outline. Anyways, what cell senescence is when cells enter this phase of their life where they no longer divide. They basically put a brake on cell division and are arrested in the G1 phase of the cell cycle. And there's numerous reasons that cells become senescent. I'm going to talk about this as well a little bit later. But I think one of the main reasons is that their telomeres, the telomeres within these cells that become senescent, are too short. And again, cell senescence is a sign of cellular aging. Next is autophagy dysregulation. Autophagy literally means self-eating. Shout out Army Hammer. And basically what's going on here is that cells in the body remove unnecessary or dysfunctional components and recycle them. So it makes some sense then when this process of autophagy is dysregulated, that cells in the body aren't able to remove dysfunctional proteins or dysfunctional organelles, and those organelles or proteins or other bad things within the cell can cause problems. And again, this is a sign of cellular aging. The last one here is mitochondrial dysfunction. This one's pretty straightforward. Obviously, when the mitochondria doesn't work as well as it should, the cell's not able to generate, or I guess regenerate, as much ATP as it needs, and the cell, doesn't do as well as it could, or doesn't doesn't have as much energy, I guess, as it needs. So again, mitochondrial dysfunction is a sign of cellular aging. So that should give you a little bit of an idea as to what a grandma or grandpa cell actually looks like. There's a lot of proteins that are aggregating. The telomeres in this cell are super short. It stopped dividing and it's in this senescent state, and it's not producing as much ATP. And you have all these dysfunctional proteins and organelles and other components that are building up because this autophagy process just isn't working as well as it should. Next, I want to take a deeper dive into cell senescence and telomeres. And the reason I'm picking these two out is because these really are the most important of, all of these different markers of aging to know and have a good understanding about for the MCAT. I want to start by talking about a scientist named Dr. Leonard Hayflick. So, before Dr. Hayflick, the common view about cells were that they were immortal. Essentially, they would divide limitlessly. They would just divide over and over and over and over. But what Dr. Hayflick noticed is that some of the cells in cultures that he was growing were slowing down in terms of cell division. And he and other scientists kind of chalked this up to contamination. He thought, maybe he put in a little bit of virus or maybe some bacteria that were contaminating the cells and causing them to slow down in division and die. However, he was a little curious about this, and so he wanted to explore it a little bit more. And so what he did is he did this experiment where he made sure everything was just perfectly sparkling clean and sanitized. And then he cultured cells and counted how many times they divided. And I'm not sure how he did this. Did he just sit there with a microscope and just watch them divide over and over? Oh, there's another one. If so, that sounds painstaking and very time consuming. But what he discovered is that cells divide a certain number of times. And this number of times was between 50 and 70 cell divisions. And that's what we now know as the Hayflick limit, or I guess what's called the Hayflick limit. And that's the number of times a single cell can divide before it stops dividing. Now, it's not important to know the number here, like the 50 to 70 cell divisions that a cell can undergo. What is important is to know the why and the what. Why do cells only divide a certain number of times, and what happens to them when they're done dividing? Now, to answer the why, I'll talk about telomeres, and then to answer the what happens to them afterwards, I'll talk about senescence. And I've kind of given you a little bit of an intro into them, but I'll take a deeper dive. Before I talk about telomeres, let me take a step back for a second. So every time our cells divide, they undergo mitosis. If, of course, they're somatic cells. If they are gametes, they undergo meiosis. But in mitosis, DNA is replicated, then these cells split into two. And during this DNA replication process, bits of genetic material at the ends of our chromosomes are lost. And more specifically, DNA is lost on the lagging strand. And essentially, the reason that this is the case is because a primer has to be placed near the end of the strand, and then after replication, this primer doesn't get filled in. And so you lose a little bit of information at the ends of these linear chromosomes each time our cells divide. Now, this is bad, really, for our genetic material. And it would be even worse if it weren't for these non-coding sequences that exist at the ends of our chromosomes. And again, these non-coding sequences are called telomeres. And these telomeres are repeats of TTAGGG. And there's about 100 to 1,000 of these at the ends of each of our chromosomes. Now, with that said, these telomeres are going to shorten with each cell division. And so really what you can do is you can take the length of a cell's telomere and you can correlate that with the number of cell divisions that cell has undergone. And thus you can actually come up with a cellular age using chromosome length. Now, once telomere length gets below a critical point, cell division is going to stop. And this is exactly what Dr. Hayflick noticed. So this is all to say that the Hayflick limit, the idea that cells only divide a finite number of times, is due to the shortening of telomeres. Again, once they get too short past some critical point, the cell stops dividing. However, lucky for us, telomere length doesn't only decrease. There's an enzyme called telomerase, which can actually help rebuild our telomeres. And telomerase is just this little enzyme that contains an RNA primer that is able to bind to and extend the telomeres. You can kind of think about it as like a DNA polymerase that's able to extend the ends of our chromosomes. Now, with all this said, the state of a cell, once it reaches the point where it can no longer divide, once its telomeres get below a certain threshold, is called senescence. And that's what I want to talk about next. Senescence is defined by Colliato and Associates in a 2007 paper as, quote, a condition in which a cell no longer has the ability to proliferate. Senescent cells are irreversibly arrested in the G1 phase of the cell cycle and do not respond to various external stimuli but remain metabolically active, end quote. So, in a way, senescent cells are kind of like old people, right? Old people are living and they're breathing and everything, but they can't really respond to external stimuli like they used to, right? They like to just kind of chill in their favorite armchair or on the couch or whatever and just watch the news all day. And, if someone comes and rings the doorbell, they can still respond to it, but it's going to take them a bit more time than it would have, say 20 years ago. So again, just to reiterate, senescent cells are cells that are no longer able to divide, and they don't respond as well to various external stimuli. However, they do remain metabolically active. In other words, they don't just die out. All right, the next thing I want to talk about here is aging at the macroscopic level. I want to talk about aging in the brain. This material, by the way, is going to show up on the Psych-Soc section of the MCAT. Now, as you probably know, as a person ages, parts of their memory and processing power of the brain get worse. However, some functions of a person's brain actually do the opposite. They get better. So it's important to understand for the MCAT what types of memory and brain functions decrease, increase, and remain the same as a person ages. So I'll kind of break these things down into those three categories. Those functions that remain stable, those that improve, and those that decrease. So first, let me give you kind of an overview of things that decrease, remain stable, and improve, and then I'll dive a little bit deeper and explain what these different types of memory or these different types of brain function are. So procedural memory and recognition memory both remain stable as a person ages. Crystallized intelligence, semantic memory, and emotional intelligence all improve as a person ages. And finally, episodic memory, recall, processing speed, and divided attention all decrease as a person ages. All right, so procedural memory and recognition memory both remain stable as we age. Procedural memory is the memory that is involved in remembering how to do specific procedures, things like riding a bike, driving a car, performing lobotomies, whatever procedure you're doing. Next, recognition memory is the ability to recognize places, faces, and objects that we've encountered. This, of course, doesn't mean we're actually able to recall what that face is, or I guess the name of the person with that face, or, the name of the place that we pass. We're just able to say, oh, interesting, I've seen that person's face before, or, ooh, I recognize that building right there. So again, that's a recognition memory, and it stays stable as we age. Now, with that said, there are three different types of intelligences and types of memory that improve as we age. Crystallized intelligence is the accumulation of knowledge acquired throughout life. It makes sense that that would improve, right? Because you continue to learn new facts and knowledge throughout your lifetime. So as you age, you're basically able to continue to add to your base of knowledge that continues to grow. Semantic memory is another thing that improves as we age. Semantic memory is the ability to recall concepts and general facts that are not related to specific experiences. For example, knowing that grass is green and that it doesn't grow well during the winter months is part of semantic memory. Emotional intelligence is the last thing that improves as we age, and that's the understanding of social situations and our aptitude in those situations. Next, there are four intelligences and memories that decrease as we age. The first is episodic memory. According to the American Psychology Association, APA, episodic memory, quote, captures the what, where, and when of our daily lives, end quote. So for instance, when we go to the store and then immediately when we get there, we forget why we went there, that's a lapse in episodic memory. And that happens more and more and more as we get older. Next, recall memory decreases as we age. And recall memory is pretty linked to episodic memory. It is retrieving information from our memory. Next, processing speed decreases. Processing speed is just the rate at which a person is able to take in and understand new information. That also makes some bit of sense. We all have grandparents who have a little bit of trouble with new technologies, new phones, new emails, whatever it may be. It's almost like they're not able to kind of process all the information required, to learn those new technologies. Finally, our ability to have divided attention decreases as we get older. Divided attention, by the way, is doing more than one task and or shifting focus between tasks. So, for example, one of my favorite things to do is watch sports, whether that's basketball, golf, football, and then listen to murder mystery podcasts. So I assume that as I get older, hopefully much older, it's going to be hard for me to do that task where I'm able to take in what I'm listening to and follow the story of a murder mystery podcast, as well as, watch and be able to comprehend what's going on in a sports game. Now, before I get into some of the topics related to sociology regarding aging, I want to cover one last thing here. And that's what causes these changes in processing speed, recall, and some of these other things that happen to our brain as we age. According to Ruth Peter at the Imperial College of Medicine in London, there are a few changes to our brain that happens as we age. First of all, our brain size changes. And second of all, the vasculature of our brain changes. So in terms of our brain size, our brain tends to get smaller over time. Quote, "It has been widely found that the volume of the brain and or its weight declines with age at a rate of about 5% per decade after the age of 40. End quote. This to me is a little bit crazy, right? Because that suggests that by the time a person reaches the age of 80, their brain has shrunk by about 20%. That's very significant shrinkage. That's approximately the difference between a grapefruit and an orange. Now, in terms of vasculature changes, it's been found that as we age, there is less and less blood flow in the brain. And then finally, Ruth Peters mentions that there are changes in levels of neurotransmitters as well as hormones in the brain as we age. But I think the big two changes to the brain are in terms of its size and are in terms of blood flow or vasculature. Can't get into a hospital or doctor's office to do shadowing? Well, you're in luck. A fourth-year medical student and I just produced a virtual shadowing video series that is also a podcast. The idea here is to help pre-meds get some kind of clinical experience during the COVID-19 pandemic, since it's pretty hard to right now. I obviously have no idea how admissions committees are going to view this. I don't know what they're going to say if you put it on your med school application, but I imagine that it's only going to help in that it's better than nothing. Throughout the recording of the series, I learned a ton, and I think you would too. So if you're interested, search virtual shadowing in your podcast app or visit shadowing.medschoolcoach.com. All right, in the next part of this podcast, I want to talk about some of the sociology behind aging. Again, I'm going to talk about aging in the life course, the social significance of aging, and the demographic structure of society in terms of aging. All right, I'll start with aging in the life course. So I first kind of want to go over what that means, just because it's kind of a little bit of a vague statement, aging in the life course. So according to the American Sociological Association, sociology of aging in the life course provides an analytical framework for understanding the interplay between human lives and the changing social structures. It considers aging to begin at conception and conceptualizes human development as a process of change involving both gains and losses across a person's life. To really fully understand what this is, let me take a step back and explain what the life course perspective is. The life course perspective, or theory, is an approach to understanding the mental, physical, and social health of individuals. It incorporates both lifespan and life stage concepts that determine the overall health trajectory of an individual. In other words, the life course theory looks at someone's whole life and uses information gained from their whole life or the perspective of their whole life to explain their current situation, behavior, or other characteristics of that person. An interesting example of this is the Great Depression. Individuals who went through the Great Depression were impacted from that well into their lives. So if you look at somebody who's, say, 60, and you were to say, okay, they went through the Great Depression, maybe you could glean something about their current situation in their 60s from them then going through that Great Depression, in their 20s or their teens or whatever it may be. The life course theory is constantly applied in medicine. And to me, it seems pretty intuitive, or I guess like common sense, that it is applied and that it should be applied. Take the following example. Say that you're a family physician seeing a brand new patient for the very first time. Now, to get an understanding of this patient's current state of health, you wouldn't just ask the patient about, their current situation. You wouldn't necessarily just ask questions like, what do you eat on a day-to-day basis? How much exercise do you get? Do you smoke? You might ask some of those questions, but you're going to ask a lot more about their past medical history and about, their situation throughout their life that has led up to where they're at now. So you might ask questions like, have you ever taken any medication in the past? Have you ever smoked in the past? Does your family have a history of cardiovascular disease, etc.? And a lot of those questions are going to be geared towards the life course perspective of health, or at least taken from the perspective of the life course theory. So that's the life course theory. Now, again, we're talking about aging in the life course theory, so let me kind of bring it back to there. Essentially, aging in the life course theory is just applying the life course theory to aging and understanding, the situation of people as they age. An organization called Help Age International talks about how aging policies can be implemented using the life course theory. It says, quote, how policies and programs are implemented affects our lives across the life course and influences our well-being into old age. In designing policies, we must look forward to their impact in our older age. But we also have to look backward and respond to older people's diverse past experiences to ensure we're achieving our goals, end quote. And the goal that they're speaking of is the goal to, quote, leave no one behind, end quote. Basically, the mission or goal of this organization, Help Age, is to promote the well-being and inclusion of older men and women and reduce their poverty as well as adverse health outcomes later in life, i.e., they don't want to leave older men and women behind. Now, with that said, the World Health Organization, WHO, goes even further. It says that, quote, societies that adapt to this changing demographic, i.e., an aging population, and invest in healthy aging can reap a sizable longevity dividend and will have a competitive advantage over those who don't. This will require a transformation of health systems away from disease-centered curative models and towards provision of older person-centered and integrated healthcare. It will require the development, sometimes from nothing, of comprehensive systems of long-term care, and it will require a coordinated response from many other sectors and multiple levels of government. End quote. In other words, the World Health Organization and Help Age say that having a life course perspective of aging is extremely beneficial and even necessary to a healthy healthcare system or the healthy functioning of a healthcare system, especially moving forward. And it says that we can focus on things like preventative medicine, understanding what happens to people as they age, and creating systems with aging in mind to kind of meet those goals going forward. So I'll summarize this all and try to kind of put it all together for you. Aging in the life course is a sociological concept that looks at the intersection of aging from birth and events that happen throughout a person's life to explain the mental, physical, and social health of individuals. And I know that's a little bit convoluted and complex, at least to me, and maybe that's just because I'm kind of adverse to psychology and sociology in general. I know it's super important, but it's just not my favorite subject. But anyways, I hope that kind of helped in your understanding of what aging in the life course is. If not, there's always great videos online you can Google search and kind of watch and maybe get a little bit better of an understanding. The next thing I want to talk about here is the social significance of aging. There's really one thing that I want to mention here, and that's that the social significance of aging is different depending upon what society you live in. In some societies, older people get more respect and have a higher status. And then in other societies, youthfulness is very valued, and then elderly people get kind of looked down upon. As an example, in the US, I think we have a little bit of both, but tend to fall into that latter category. And this is kind of my own experience speaking here, but I think we respect knowledge and wisdom that old people have, yet we tend to kind of see their oldness as maybe a little bit of a weakness, or, that they can't function on their own, or, when you get old, you can't really do the things you used to be able to do. You're not as youthful. And that's evidenced by the fact that many old people just end up in retirement homes and they're kind of isolated from the rest of society, pushed to the side and said, you live over here. The rest of society is going to live over here, and we'll come visit you every once in a while when we feel like it. Also, I think there are some situations where in the US, it's like you look at your grandparents or people who are older as maybe being dumb or just like not knowing what they should know. And it's not that way everywhere in the world. And again, I'm just kind of speaking from the cuff here as to what I've seen, on social media and those types of things. I don't know if the majority of people really believe that, older people tend to be dumber or, narrow-minded, things like that. I'm just going from my own observations. Now, with that said, in cultures where multi-generational housing is the norm, and it's expected that the younger take care of the older, and at the same time they learn from the older, and the wisdom is passed down for people who are older to younger through that fashion. And this, of course, happens in the US for sure, but maybe just not as much as in other countries. Anyway, really the takeaway point here is that different cultures treat old people differently. In some, they're respected, and then in others, they might be seen as weak. Finally, the last thing I want to talk about here is the demographic structure of society. In terms of the demographic structure of society, in the US especially, the population is getting older and older and older. Right now, the median age in the US is about 38 years old. If you go back to 1970, this was 28 years old. Also, the percentage of the population that is older than 65 has gone up pretty significantly over the past 20 to 30 years. You can see this quite clearly on a type of graph that you might see come up on the MCAT. And this type of graph is called a population pyramid plot. And essentially, you could compare the population pyramid plot from, say, today, 2021, to 1970, and that would give you a really good picture of how the population has changed, or at least how the demographic structure has changed. Now, these population pyramid plots have age group bins on the y-axis and relative population size on the x-axis. For younger populations, they're pyramidal in shape. Basically, the lower age bins are bigger. However, for older populations, like those today, these plots become more top-heavy, and they start to look more like a house than a pyramid. So with that said, make sure you know how to interpret these plots. I think it's pretty straightforward, but if you've never heard of a population pyramid plot, or this doesn't ring a bell when I describe it, just go Google an image and make sure you know what it's saying and how to interpret it. Now back to the aging US population. There are really two big reasons that the US population, as well as populations really all over the world, are increasing in age. The first is the fact that life expectancy has increased. The second is that people are having less children. So as a result, people are living longer, there are less babies being born, population is going to get older. That makes pretty logical sense. Now, what does this mean for society? Well, aging populations can put stress upon the healthcare system. As people get older, they tend to, on average, have more illnesses and more need for medical care. And this is where preventative medicine can play a really important role. If we're able to prevent illnesses before they occur in older populations, it's going to be less burden on the healthcare system. I kind of talked a little bit about that earlier when I was talking about aging and the life course. But again, the short of it is that an aging population puts pressure on the healthcare system, and we need to, in turn, respond by creating systems that better care for aging populations, focusing on preventative medicine, etc.
At Med School Coach, we know that getting into medical school is hard. In fact, 60% of pre-meds who apply to a medical school don't even get accepted. And if you want to get accepted into a top medical school, it's even harder. That's why more students than ever are turning to MCAT tutoring by Med School Coach. Our tutors are all 99th percentile scorers, have been through rigorous training, and can help raise your MCAT score by 12 points or more. You need every competitive advantage you can get to get into med school, so why not get one-on-one tutoring from Med School Coach? Our expert team will create a custom program just for you and help you master MCAT content where you need the help most. You'll raise your MCAT score. We guarantee it. Visit us online at medschoolcoach.com and use offer code PODCAST10 to save 10% up to $400 on a Med School Coach MCAT tutoring package. You can achieve your medical school dreams, and Med School Coach can help.
All right, that is it for the Aging podcast. I hope you found it useful in your studies. As always, if you like what we do, leave us a review on iTunes. It helps us in the rankings. Tell your buddies who are studying for the MCAT about it. Tell your pre-med friends, whatever it may be, that there is this free resource out there for you to study with.
Each episode of MCAT Basics is brought to you by Med School Coach. To access Med School Coach services, including MCAT tutoring and medical school admissions advising, visit our website at medschoolcoach.com. Good luck as you prepare for the MCAT, and we hope you tune in again next time.